The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone. Welcome to the pre-startup safety review process, an overview, tips and tools for ensuring operational readiness webinar. Your presenter today is Jodie Olsen. Jodie is the Principal Engineer and Manager at J.E. Olsen Consulting. Jodie has been a process safety consultant since 2016. Her expertise is in the implementation of various process safety management elements, including process hazard analysis, management of change, pre-startup safety review, root cause failure analysis, mechanical integrity, and other elements. Prior to this role, Jodie spent nearly 3 decades working in upstream oil and gas production for Mobil Oil, Era Energy, and BP. During this time, she worked in roles involving the application of process safety management practices, process safety engineering, reliability engineering, project implementation, and general plant and operation support. For over 27 years, Jodie worked in field-based engineering roles. With this background, her focus is geared towards practical field applications of process safety and improving the efficiency of work processes. Jodie has a bachelor's degree in petroleum engineering from the Colorado School of Mines. She is a registered professional mechanical engineer in California and Alaska. Jodie has presented papers at conferences including the Global Congress on Process Safety, Mary Kay O'Connor Symposium, and iChemE Hazards. Jodie has been published in Process Safety, Progress Journal, and other trade magazines. I'd like to take a moment to advise all attendees that we do have a questions and chat box. If you could put questions in there as we're going along today, and we'll be able to have a Q&A session with Jodie at the end. Okay, Jodie, are you happy to continue?
Sure. Can you hear me, Craig?
Yeah, loud and clear, Jodie.
All right. Well, thank you for that introduction, and thank you for getting up in the middle of the night, Craig. I also want to thank iChemE and specifically Trish Karen for asking me to talk with you all today through this webinar. Today, I will be talking about the pre-startup safety review process, also known as operational readiness. I'll be providing an overview of a typical process along with some tips and tools that can support, hopefully, better PSSR and operational readiness practices. As you can hear from my voice, I'm from the US and I'm speaking to you today from Alaska. I wanted to acknowledge that I'm speaking to an international audience and recognize that we're all working in different regulatory frameworks. But regardless of how your regulations are written, we are all working towards the same goals of keeping the product in the pipe or in the processing equipment. And of course, our primary goal is to keep people safe and to protect the environment. The management systems and elements and frameworks that support those efforts all tend to look somewhat similar across different areas and jurisdictions. So hopefully what I'm presenting today aligns with your framework and offers a few specific practices that may help in your implementation. So with that, I'll move on to the first bullets on this first slide. I did want to highlight that pre-startup safety review, PSSR, was identified as one of the 14 elements defined in the 1992 US OSHA Process Safety Management Regulation. This is why we tend to use that terminology in the US. That element is related to management of change, which was identified as a separate element within that regulation. So now different regulatory bodies and different entities may define their own similar but slightly different constructions of process safety management systems and programs. The Center for Chemical Process Safety, CCPS, developed their risk-based process safety guidance, which is comprised of 20 elements. And the CCPS element that aligns with PSSR is called operational readiness. So one thing that CCPS made a point of doing when they defined the element was to highlight the fact that operational readiness applies to not only projects and MOCs and construction work, but also to assuring the operational readiness of equipment that's being returned to service after other work activities like maintenance or inspections or repairs. And to highlight the importance of operational readiness and PSSR, pre-startup safety review, we don't have to look any further than the tragic 1988 Piper Alpha incident. And we find an example of a catastrophic event that stemmed primarily from a restart activity where the equipment was not operationally ready for that startup. You may be aware that this incident involved equipment, specifically a relief valve, that had been removed from service for maintenance activity. It was loosely capped with a blind flange. When the pump that was operating in parallel went down and could not be restarted, the sister pump was started, and that sister pump was the one that was in line with the relief valve that had been removed. The blind flange that had been loosely attached at the location leaked and precipitated this incident. So our purpose with pre-startup safety review and operational readiness is to ensure that the equipment that is returned to operations is safe and ready to start up and operate. We want to ensure that all of the approved project design elements have been installed as they were intended. We go through great effort when we're doing MOC reviews, when we're doing design reviews, when we're doing PHA, to assure that we've given this a thorough review. And so the intent with PSSR is to make sure that all that work that went into the design actually is what ended up in the field. And when I say projects, I'm talking about all the way from very, very large projects to the very, very tiniest little MOCs. So the full range and everything in between. And of course, as was highlighted with the Piper Alpha incident, we also want to ensure that equipment is ready for restart following maintenance, inspection, and repair work. We need to ensure that the equipment and the safeguards are all in service and operational. We know that a high percentage of failures occur during transient operations, including and especially startup. But it's not just during that startup phase that we're concerned about, because we want to ensure that we don't embed hidden or latent hazards into the process that then may be exposed later through an incident. So the other thing to keep in mind with PSSR, operational readiness, and all process safety elements is that these are just good business because it facilitates successful projects and safe and reliable operations. I do want to note that as I go through this talk, I may use both terms, PSSR and operational readiness. I tend to use PSSR a bit more often simply because it aligns with our regulation and we're accustomed to the term, but the intent is that both terms can be used interchangeably. Likewise, I sometimes use the word project, and when I say project, I mean that full range of size of projects, all the way from the largest implementations to the very tiny MOCs, and including those maintenance activities, which could be construed as a project. So I wanted to mention that a version of this talk was originally prepared in 2021 for the Global Congress on Process Safety, and then an article stemmed from that talk that was published in Chemical Engineering Progress last year in June. So I just wanted to mention that so that you're aware that there is follow-up information available after the talk, and I can provide links to that reference information. In the CEP article, the article basically outlines the who, what, where's, whens of how we do pre-startup safety review. It's organized as you see up here on the slide and with these elements. The talk that I'm giving today is organized similarly, but just slightly differently. These are the points that I'm going to be walking through during the talk. The other thing that I wanted to mention is that all of what I'm going to be sharing in this talk stemmed from actual work experiences in the field. There was multiple instances that I was involved in where we were having issues or problems with our pre-startup safety review process, and we were able to make changes to those processes, either a small tweak or maybe a complete overhaul. And following those changes, we felt that we had a much more successful program. So that's where this information was derived from, and that's what I'm going to be walking through. So I'll start with the first bullet on this list, the workflow process. So this is a simplified workflow diagram for a basic pre-startup safety review process. And the steps that I'm going to be covering regarding pre-startup safety review, operational readiness, are shown here in the middle. And then also shown are the stages leading up to PSSR and the stages immediately following PSSR. One distinction that I did want to make with regard to the talk today and also the article is both the talk and the article are geared towards the activities that lead up to that project turnover to operations. Now, depending on how different companies draw the line, there may or may not be final pre-startup activities that are conducted by operations immediately before startup. And so all of the activities are absolutely critical PSSR activities. I did just want to draw the distinction that with the talk and with the article, I am really focusing on leading up to that handover process when the equipment is handed over or handed back to operations. The way this diagram is organized is basically in swim lanes. And in this lower rung, we have the administrative tasks and activities that are associated with PSSR. And those are going to include things like gathering up our drawings and our documents, ensuring that our data systems are fully populated. That could include the CMMS system, the computerized maintenance management system, your HMI screens, of course, your equipment databases, your enterprise systems. You also want to make sure that all your procedures are complete and ready to go, and that you've had training on all the critical procedures that are required for your startup. In the upper rung, these are the activities and tasks that occur in the plant or the field. These are the on-site activities and work steps. And these are the steps that are the primary focus of the talk today and are the focus of the article primarily. I'm going to start out by talking about the on-site inspection process. The on-site walkdown or the on-site equipment inspection is a key part of pre-startup safety review. One of the first considerations that you need to take into account is assembling the correct team. The on-site walkdown is inherently a multidisciplinary and a multifunctional effort, as is the entire pre-startup safety review process. It occurs at the transition point where a project team or a project group that's responsible for implementing a project is getting ready to hand over that equipment to operations, or by the same token, when a maintenance group is getting ready to hand back equipment that's been inspected, repaired, or refurbished to operations. So it's very important to select a group of individuals that have the proper skills and background and experience and aptitudes to properly represent those roles and those functions. You want to make sure that the group is right-sized. You want to make sure that it's not too small and it's not too large. Inherently, because of the fact that this is a multifunctional, multidisciplinary effort, a single individual is not going to be sufficient to conduct the on-site walkdown. On the flip side, you want to be sure that the group is not too large. As you're probably aware, when you have a very large group, the individuals tend to get lost in the crowd, and so those individuals may lack accountability or ownership and may just be less invested simply because of the group size. There are also logistical and practical considerations for assembling the right size team to do an effective inspection in a plant environment where that team of individuals has to be able to put their eyes on the equipment. So an appropriately sized inspection team is probably going to be on the order of 4 or 5 individuals, plus or minus, but probably somewhere in that range. So group walkdowns are an important piece of the overall PSSR process for projects of all sizes. And it's important that all key stakeholders put their eyes on the equipment and walk the job down together. They need to be able to agree on what's acceptable and what items are not acceptable and will require follow-up either before or after startup. So while the group walkdown is important and it should occur on every PSSR, for projects that are slightly larger or may involve equipment that's slightly more complex or may have functional testing requirements, an individual walkdown generally should precede that group walkdown, or that's a good practice to consider. There's a couple reasons for this. The group walkdowns themselves are simply not that conducive to conducting a thorough and detailed individual inspection. The individual team members will just not have sufficient time and space to conduct their own detailed inspections if they're visiting the equipment in conjunction with the group. They're going to probably feel constrained by group time pressures, group dynamics, and potentially group think. The second reason for doing 2 separate walkdowns relates to making the PSSR process more time efficient overall. By conducting an on-site inspection first by individuals, and then by assimilating their lists of follow-up or punch list items into a single list, then those punch list items can begin to be addressed at the same time that functional testing occurs and some of the other activities are occurring. Then that work is followed by the final group walkdown and confirmation that those pre-startup required items have been completed. And one note, in the article, I do share an example of a workflow process for a small project where a single group walkdown may be sufficient. An example would be where, an example of where a small an example of where a single group walkdown could work is where you may have a very small job and there's no functional testing required, and perhaps it may be repetitively implemented. An example would be a project that I was involved with where we were replacing well flow lines throughout the field, but each individual flow line replacement required PSSR and a group walkdown. So in this case, because of the size, scope, simplicity, and repetitiveness of those installations, a single group walkdown was sufficient. So moving on to equipment checklists, you're going to begin to see a similar theme developing here. You want to be sure that your checklists are not too simple. They're specific enough for the equipment that you're inspecting that they're useful. You want to make sure that you have enough checklists to cover all of the equipment types involved. However, at the same time, you want to make sure that you're not too overburdened by too many checklists or that they're not too cumbersome or too long. In the article, I provide an anecdote about a company that was struggling with their PSSR processes, both for their very small project implementations, these would be the tiny, very tiny little MOCs, and also for their very large project implementations. They were dealing with problems on the opposite ends of the spectrum. For their really small MOC implementations, the teams were only given a couple of checklists to use, and they had very simple criteria, but they did not provide sufficient guidance to the teams doing the inspections in the field. On the flip side, the large project teams had some very involved project turnover processes. It was PSSR by a different name. They had lots of meetings, lots of forms, lots of signatures, lots of sign-offs, and they were doing a pretty good job with their functional testing, but with respect to equipment inspections and walkdowns, they were not inspecting their equipment to a checklist that provided a listing of criteria. And as it turns out, they actually had binders full of very detailed equipment checklists. However, none of those checklists were being used. So it's important to recognize that the checklists that are used in the process need to be effective. They need to support an effectively implemented process that's not overly cumbersome, but has a sufficient amount of detail. So next, another important thing to consider on your equipment checklists or walk-down forms is to always include acceptance criteria on the actual checklist that's used in the field. This slide shows some examples of excerpts of checklists where on the left side, you can see that there is no acceptance criteria shown. You can see that there's insufficient detail describing what the person performing the walk down should be looking for on those particular line items. The example of the excerpt on the right shows better description and better detail for each individual line item, and that includes acceptance criteria. It's important to recognize that acceptance criteria needs to be available on the checklist to all of the inspection team members that are using the checklist during the walkdown while they are in the field. You don't want that information buried in books on shelves or in file folders where people are not going to be able to see it at the time that they need it. Of course, there's limitations on that. Again, you have to find the right balance. But the critical criteria should be shown, and the threshold that defines what is acceptable versus what is not acceptable should be available. The unacceptable, all of the unacceptable items will require follow-up. Another important thing to recognize is that for any equipment type, it is the equipment that defines the standard that the equipment is installed to, inspected to, and tested to, not the implementation group. If you have a very small project that's installing, say, a single control valve versus a very large project that's installing a very large number of control valves on a wider set of equipment, each control valve, whether it's associated with the large project or the very, very small project, has to be installed, inspected, and function tested to the same standards. Again, it's the equipment type that defines the requirements, not the equipment, not the group involved in the installation. Another thing that you want to be cognizant of is the relevancy of the items on the PSSR checklist relative to the PSSR stage of the process. So this is an example that shows a checklist that has a lot of very important criteria on it. However, some of that criteria is not appropriate for the PSSR stage of the process. Although these are very important items, they must be dealt with at other stages, some of them. For example, relief devices and lines being adequately sized. Clearly, that's a critical item. It must be dealt with, but it must be dealt with up front during the design stage of the process. During PSSR, we're not designing the project and we're not checking the design of the project. What we're concerned about is assuring that the equipment that was installed matches the sizing and selection of the equipment that was approved for the project. That happens through the on-site walkdown. And on the administrative side, you want to assure that those checklists and that those calculations and those equipment data sheets are all gathered up and then they're loaded into the proper accessible location and that people have access to them after startup. Likewise, sometimes there are items included on checklists that may not be able to be inspected after installation. And some of those items are going to need to go onto pre-construction or during construction checklists. So this is a very important slide. This slide addresses changes from the approved design. These are sometimes called red lines and may be referred to as built, especially when the as-built drawing does not match the approved drawing. Now again, to reiterate, what we're talking about here are changes that have occurred to the design after the MOC reviews are completed and approved. and after the process hazard analysis is completed and approved, and after the construction drawings have been approved and issued. So we have to be realistic here. We live in the real world. We know that changes occur. That's real life. We have to accept that change happens. Yes, we recognize that, and we have to acknowledge that changes will occur. But the question is, were the changes approved through a fully equivalent process to the MOC process? And I want to put a caveat on that, to a good, thorough MOC process. Sometimes construction groups with best intentions may design their own change management processes to deal with the myriad of change orders that they may have to handle as they go through the life of the project. But if they do that, then that process must be fully equivalent to the MOC review and approval process. So I actually had a personal experience with this, where I was working with a construction group. I was the plant engineer, and we were talking through some changes that had come through, and I was trying to understand their change order process that they used to manage these changes that were passing through. Because I started to wonder, well, like who's looking at these, and what if they're making a change that's impacting the design, that's impacting things that were reviewed and approved through the MOC or through the PHA? Were they identifying the process changes that might come through? And the individual that was showing me the form and the process, he was probably some sort of foreman or supervisor, and he said, "Oh no, we've got it handled. There's a box right up here, and it says, do you need a process hazard review associated with this change?" And they had a box to check yes or no. Do you need that? Well, so I started looking through a variety of change requests that had come through, change orders that had come through and been changed. And it didn't take very long to find one that was actually a process change that had come through the system. The box was not checked to identify that a process hazard review needed to be done. And this particular change, they had altered the flow path, they had changed a tie-in point, and the tie-in was altered from in one end, in the before it was either upstream or downstream of the valve, and after the change it had been moved to the other side of the valve. So that was clearly a process change, and it needed to be evaluated whether it had an impact or not. My suggestion to them was, we had just gone through a process with the MOC process to try to improve our screening for finding those process changes for MOCs that came through. And we had developed a fairly involved checklist screening tool to look for those process changes and to better evaluate when we had a process change. My suggestion to them was, why didn't they just apply the same screening tool, the same screening form to their change management process, and apply that to every change that came through, answer the screening questions. So that's just an example that I was involved in or became aware of. But the thing that we do have to be aware of is that when we find these changes that have occurred after the fact, and we're finding them during the PSSR review, we have to assure that they were adequately reviewed. And in some cases, such as the case that I just laid out, those changes may have been under-approved. And those changes, if we find an under-approved change like that at this stage, they're going to need to get a full review at this point. They're going to need to be looked at very closely. By the same token, there may be changes that are found that people were simply unaware of, that didn't even make it through the change order process. And in those cases, those are fully unapproved changes. So although belated, those changes, whether they're under-approved or unapproved, must receive fully equivalent, and remember, good MOC reviews and good process hazard analysis before those changes can be approved and before startup can occur. And it is important to recognize that there must not be an assumption going in that those changes will be approved or should be approved. And there should be recognition and acceptance of the fact that that if the changes are found to be unacceptable, this is going to impact the project timing and the cost. So now another quick sidebar here. I just wrote and presented a paper for the Global Congress just a couple of weeks ago. And in one part of that paper, I made references to Admiral Rickover and the US Nuclear Navy. If you're not familiar with the US Nuclear Navy, it's somewhat revered for their safety and their reliability performance record. The Nuclear Navy, the US Nuclear Navy, was built based on what is now referred to as the Rickover Principles by Admiral Hyman Rickover. One of the Rickover Principles is facing facts. And this is a good example where findings are discovered very late in the process, and it may be inconvenient, but we need to face facts and we need to address them completely, and we need to deal with the consequences of what we find. So when we're reviewing these changes, these things after the fact, we have to recognize that there's potential bias built into the process. There's bias built into our review process because the change has already been installed and we know the implications of a problem. So we really have to guard against doing insufficient or light reviews if we're doing it too late, if we're doing it late in the process. And this is an area where we need support from management to help find mechanisms to encourage those findings and encourage those thorough reviews. We need to avoid pressure from management that could actually drive things in the other direction. So clearly, we want to avoid these unapproved and these underapproved changes. So once we finally get through all of them and the project is finally completed, so it would be a really good idea to do a full post-mortem review, including some sort of failure analysis, so that we can try to understand why these underapproved or unapproved changes are being introduced into the process. So this slide is a little more straightforward and will be a lot quicker. This is addressing the follow-up closure items, and I say that it'll be more straightforward because we deal with follow-up items throughout our project. It's not an unusual thing. We deal with follow-ups when we do our design reviews, when we do our technical reviews, when we do our PHA recommendations. All of these generate potential follow-up items, just like the PSSR walkdown can. So the important thing, though, when we have follow-up items is that we deal with them correctly, completely, and that those things all get closed out properly. So when we find an item on the PSSR walkdown that requires follow-up, first we need to define several things about it. We need to define the deadline, and importantly, we need to clarify whether that's going to be a pre-startup required item, or there may be a few that actually occurred during startup, or a post-startup, or allowed post-startup. And in conjunction with that, it's a good idea to define what the drivers are. Is this a safety issue? Is this a compliance issue? Is this operability? Is this a policy or procedure issue or better practice? There very likely may be more than one driver, but that is good to know as we're defining the requirements around it. We need to define an owner who will address this, who will take the lead, and we need to address the closure requirements. It's really important to realize that we have this, if we have this very good process around PSSR, we don't want to we don't want it to sort of lighten up as we go through the closures of these individual follow-up items. If we needed multiple people to put their eyes on the item as we went through PSSR, if it needs to be closed at a later date, you may need all of those same eyes on the item to go through the closure of it. You may require functional testing, and then there may be some instances where it's truly a more administrative item that maybe you don't require every set of eyes on that, but you need to clearly define, is this a company person that needs to look at it, or is this such a simple or administrative item, and not simple is not the right word, but an administrative item that won't have safety consequences, that maybe a contractor could sign off this particular item. So next I have a red flag shown here on deferrals. Anytime there is a suggestion to defer an follow-up item that was identified from the pre-startup safety review as pre-startup required. If there is a suggestion or proposal to push that back to a post-startup item, there needs to be a really good discussion around that and consensus from the PSSR team members who originally assigned it as pre-startup required. So that should never be done lightly and should really be avoided if at all possible. And the same applies to any cancellations or dismissals. Those need to be routed through the people that said that this is an item that we need to address. And I think I've already addressed the closure by completing it and fully signing it off. With this slide, I want to highlight and emphasize the point that the client or the customer of the PSSR process is operations, or more specifically, the operator. To make that point, I wanted to share another anecdote, and this was one that was in the original Global Congress paper, but it didn't make it into the CEP article. And so in this example, I'll continue the story that I mentioned earlier regarding the field-wide project that involved many well flow line replacements. In this case, we're talking about a PSSR process that was developed not because of regulatory requirements, but because the operator customer was continually dissatisfied with the turnovers that he was getting on this construction project that was being implemented in multiple phases. So rather than letting our operator be continually frustrated, we got the group together and we developed some PSSR criteria, we developed the work process, we developed a checklist, and we began implementing that process. That process included a group walk down involving the operator, the construction crew foreman, the construction superintendent, and the engineer. And at the end of the day, all of the stakeholders were much happier with how things were transpiring. The operator was happier with his turnover, and that's saying a lot because this operator was not easy to please. He took a lot of pride in his work and he had rigorous expectations. And the construction crews were pleased because they were able to deliver to a satisfied customer. And they were happy to know what the criteria was that they were going to be measured on. And of course, I was happy as the engineer on the project that we had made these improvements. So again, this project occurred in an oil field where this part of the process was not regulated by OSHA PSM. So it just reminds us, and we want to recognize that although PSSR is a requirement for certain regulatory compliance, because it allows us to have safe and reliable operations, that we're going to protect people, the environment, and the equipment. Because we're protecting all those things, it leads to successful business outcomes. And finally, I want to highlight the fact that, of course, by its very nature, PSSR occurs at the tail end of a project process. And you have to be very cognizant of the fact that people are tired at this phase of the project. Everyone wants to get this project completed, and there is simply project fatigue that has set in, and people just want to get the equipment up and running. So it's very important, once again, to look for mechanisms and triggers to assure that the PSSR process is done in a thorough manner and that it's not given a light touch. And management and leadership are essential in this effort because management often sets the tone and in some cases sets deadlines or incentives that may push people for an earlier startup that can conflict with that goal. So the key is to look for mechanisms and triggers that can drive the opposite behaviors and incentives to encourage thorough review ahead of earlier startup. And that just reminds us of the good, fast, cheap triangle. Remember, when we pull too hard on one side of the triangle, we pull away from the other side. So the other thing to remember is that fast is a relative term here. We're talking about how fast the PSSR is done, not the project itself. The PSSR will require the time it takes to do a thorough and complete job, and that's regardless of the overall timeline of the project. So my final summary slide, and I'll just quickly go through and highlight the things that I've already spoken about here. And that's some things to remember about PSSR is we're looking to find the right balance, that it's not too big, it's not too small. We're looking for the right number of participants on our walk downs. We don't want too many, but we can't have too few. We need the right number and scope on our checklist. We don't want a process that's so overly cumbersome that it weighs itself down, but it has to have enough information and detail on it that we can do a good job with our reviews in the field. We also want to look at that workflow process. In most cases, we're probably going to, we may need to have two walk downs where an individual walk down is done first, followed by a group walk down, but there may be instances on some of our small jobs where a single walk down could be sufficient. So we need to establish those effective on-site walk down practices, and those are supported through effective equipment inspection checklists. Again, I already mentioned having that criteria, good concrete criteria that describes the thresholds and the acceptance criteria. We want to beware and really take a hard look at any unapproved or under-approved changes that have passed through the system, and those have to be dealt with completely, even while they're being done after the fact. And we want to be sure that we're doing complete follow-up item closure. And we want to recognize that while this is a multidisciplinary effort, the operator is the primary customer. And beware of project fatigue and how that could impact the quality of our pre-startup safety review and our operational readiness practices. And finally, remember, just like all of the PSM elements, is good business, because having safe, reliable equipment not only keeps people safe, it's good for business. So this slide has some links to the article. Obviously, you can't click the links here necessarily, but you can access those various different places. I have the article posted on my website. I also have posted on my website some examples, or an example of a PSSR walkdown form that is actually the expanded view of one of the excerpts that I showed in the talk. There's also a link shown to what I referenced in the example talking about the construction situation, where they were using a process and they were passing through some of the requirements for hazard review. And so there's an example of a process safety screening form up there as well. Oops, that's not what I wanted to do. All right, I just clicked the link instead of the slide. All right, so that's the end of my slides, and so that's the end of the presentation. And I'd be happy to take questions right now. I did have one little bonus slide here that I just wanted to mention, that attention to detail is so important. That was actually another Rickover principle, or is another Rickover principle. And this was just a short list of some findings that I found, more PSSR problems that I found, just in doing a very short screening of different things that I happen to become involved in or aware of. And when I took a look in these instances, I found problems. More often than not, I would find problems with either findings that didn't get called out, even by the quality control people when I did the inspection behind them, PSSRs that were entirely missed. You see the example there where we had an MOC that went through and the modified valve never got installed, was never walked down. And these things were happening routinely. It didn't take me long to find this number of mistakes based on the quantity of jobs that I looked at versus this list of mistakes was a pretty high percentage. So attention to detail is very important. So I'll go back to the other slide. So that's all I have. If you want to ask any questions, please feel free to go ahead.
Jodie, thanks very much for taking the time to provide the webinar and presentation today. So just please, if you do have questions, again, populate them in the questions box, please. At the moment, we do have one, which is, what situations have you seen that would indicate project failure? Sorry, project fatigue.
Oh, project fatigue. Well, I don't know that. Well, I'll give you one that just comes to mind. I mean, this is just on a closure item. I mean, I think it's just it's really prevalent. I mean, anybody who's at the end of a project feels it. I mean, people want to get done. I can give you one specific example of where I would say project fatigue led to the construction engineer. We had called out an item as a PSSR follow-up item that needed to be addressed. There was a valve that was actually removed, I believe, and we had replaced that valve with a dummy spool. And in walking the job down and doing the final equipment walk down in the field, you know, I noticed it was my job that the dummy spool actually looked like a live leg. It actually looked like a live part of the process, and you would walk by it and think that that was part of the process. And so I just recommended that we put a label on it that said dummy spool, and that was a simple thing to do, but labeling was harder to accomplish in this particular location than it really should have been. And this particular project engineer just really wanted to get these closure items done. And he said, well, do we really need to do that? You know, if you actually look at it closely, you can tell that that is not a weld neck flange. And since it's not a weld neck flange, then, you know, somebody would be able to look at it and see that it's actually not a live spool. It must be a dummy spool. And I just kind of rolled my eyes. I was like, you know, I know we want to close out this item, but that is a very hard thing to discern. Nobody's going to think that when they walk by here. People are going to think this is a live line. We need to just put a label on it. And so, yeah, you know, it's better to close things up properly than to just say, hey, let's just check off items.
Yeah. I do have another few questions here. One is, I think the PSSR report is a live document.
Excuse me? Well, what was the question?
It's a question around, is the PSSR report a live document?
The PSSR, well, I mean, it can be constructed different ways. The way that I've dealt with PSSR, so I didn't even fully get into this in this presentation, but usually there's kind of like a master PSSR checklist that's going to include all of the administrative tasks as well as the tasks that I was more focusing on today, like some of those equipment walkdowns and things like that. And so there's going to be a comprehensive list of items that need to be dealt with. I actually personally am an advocate, and this sort of gets outside of the realm of PSSR, that when we're managing projects and we're managing changes, that there's kind of a live list of project documents that actually sort of tracks through the entire project, and so that where the PSSR piece of that just becomes on stage where that documentation is going through, and it's going through at the PSSR stage. So there's various different ways that companies may put their programs together. I like the idea of the program being more holistic like that, and not constructing separate entities, separate documents just for this one phase, when these documents relate all the way back throughout the process and could be managed more holistically through the project way before PSSR even starts. But then different elements of those have to be signed off at the PSSR stage, and certain ones are startup required and certain ones are not, or certain ones may not be applicable to that particular project. So that's a little, broader question than I guess what I was totally focusing on in this talk. but it's a good question, because I think you can do a lot of good by sort of managing those things holistically. But yeah, in the PSSR, you would deal with, like, if you could just talk about this specific equipment checklist that I was talking about, like that type of checklist would be kind of a standalone item. What we would do on a larger project is we would take the follow-up items and we would load those over onto an action item list. But for a very small project, like the one I mentioned with the field walkdowns, we actually handled our follow-up items right on the field walkdown form, and that was the entirety of the documentation right there, because it was a small enough project that we could do that.
Yep. Okay, we've got another one in, and it's, could you provide some examples of good PSSR team for a newly installed high pressure trip system involving new pressure transmitters, new isolation valves, and new depressurization valves?
Can you repeat that question one more time?
I think the question would be around, could you provide some examples of good PSSR teams for newly installed high pressure trip systems?
So what participants to be involved in like an instrument of function like that?
I would assume probably disciplines and experience.
Yeah, I kind of hate to do it off the cuff because I probably will miss something right here, but yeah, you are going to construct that team based on all the critical disciplines that need to be involved. You're going to probably have some instrumentation people there. You don't want to forget the mechanical side of those safety functions as well. So they're going to require a mechanical review. There's going to be instrumentation reviews. There's going to be functional checkout. And if I tried to put a list together right now, I'm sure I would miss someone. So I'd kind of hate to do that. In the paper, I do kind of draft out just some examples of, constructing teams. Obviously, that's not going to cover every instance or every type of equipment. But that the paper does have a few examples of just some team members to think about for constructing those teams, but they do have to be individually developed for whatever the particular item is that you're looking at.
Okay.
And don't forget both sides, both the instrument side and the mechanical side for all of them.
That's an excellent point. Got time for one more. There are cases where we face same change on more than one similar process equipment. Do we need to carry out PSSR on each similar process individually, or can be done as a combined safety review?
Well, that's really similar to the case that I was talking about, where we were doing a widespread campaign, a large project to replace flow line after flow line after flow line after flow line, and you may have a totally different, scope that you're talking about for your repetitive work there. But no, absolutely, you must look at every individual installation independently, because just because it's a campaign or it's something that's being done over and over again, there can always be differences. There can always be something that was missed. And each one requires that individual walk down and review. Now, like I said in the example I gave, because we were doing this repetitive task, that was one that made sense to, we didn't require 2 visits from every team member, and we didn't require, so we certainly didn't require 2 group walk downs or anything like that, but we did have 1 group walk down for every line. And more than likely, I wouldn't be surprised if some of the key participants, maybe they did visit it in advance.